Alright, so looking at some of the basic parts of transformation using matrices. There are a lot of ways. So you have rotation, enlargement, and translation that you can use, and reflection. So matrices are able to do all 4 types of transformation depending on the matrix used. So in this particular question, there are different things you must think about. You have to look at the matrix given and the coordinate points, and that will help you to figure out, am I doing reflection, rotation, or anything like that. Now, in this particular question, it says a transformation T is defined by the following 2 by 2 matrix. T equal 1 to K negative 1, where K is a constant. T maps 2, 3, or the point 2, 3 onto 8, 5, 8, 15. Determine K. Now, the fact that this is a 2 by 2 matrix and these are individual points, which would basically be a 2 by 1, it tells you that it's not translation, because translation would be adding matrices and they have to be of the same value, same amount of numbers, or the same order as well for it to be added. Now, once you're doing matrices and transformation, most of the times, once you have the actual numbers that you're using, you put the matrix first that is being used for the transformation. So in this case, it's T that's the matrix of transformation. So 1, 2, K, negative 1. So that's the matrix of transformation. And then you'll put the coordinate that was the original, based on the fact that this changed the original to something else. So the original was 2, 3. And that is equal to alright, so if you realize the coordinates, they were horizontal, but now I'm writing them upwards. That's because if we should keep it horizontal, there's 2 reasons. So vectors or matrices, you generally write them vertically. That's the general format that you write them. Now, if you had kept it horizontally like you see it here, this order would have been 1 by 2, and this is a 2 by 2. So they could not have been multiplied together. You couldn't use them to do anything together. But now that you change the orientation, this is a 2 by 2, this is a 2 by 1. And therefore they are able to be multiplied together. Now, once it sets like this, it becomes basic multiplication of matrices. So it's a row by column. So it's a first by first, second by second. So you'd say 1 times 2 plus 2 times 3. And then you do the same thing for the other row. So K times 2 plus negative 1 times 3. Now, matching these equal. Now, you could have written 1 equal and it works out. Or you can split it apart. Now, if you realize this is the top row, so therefore it must match back to the top row, which is 8. Bottom row, bottom. So it matches back to 15. Now, if you work this out, 1 times 2, that's 2, plus 2 times 3, 2 times 3 is 6. So 2 plus 6, 8. So you know that this is already finished because you don't have any letter in it, because you're trying to find K. So you're focused on this bottom row now. So this means 2K minus 3 is equal to 15, because negative 1 times 3, negative 3. And then for this now, it's simple solving equation, or we may say transposing to get K by itself. So you are trying to get rid of first the 3. Now, since it's a negative 3, you do the opposite, which is to add. So basically you'd add 3 to both sides. Or in shortcut, we normally say we bring the 3 over and change this sign. So 2K is equal to 15 plus 3. So 2K is equal to 18. And you do the same thing. You want to get rid of the 2 so K can be alone. 2 and K, they are multiplying each other. So you do the reverse or the opposite to undo. And the opposite of multiplying, we know, is dividing. So you divide both sides by the 2, and so k is equal to 9. So k would be equal to 9, and you would have been able to get your answer, and that's it. So it's basic multiplication for it in cases like this. Now, it could have been reworded in other ways. So for example, with this one, this says a right angled triangle. M has vertices x, which is 1, 1, y, which is 3, 1, and z, which is 3, 4. When M is transformed by the matrix N, 0, 1, 1, 0, find M inverse, the image of M, sorry. Now, once you get this, it requires you to do multiplication once again because it's a transformation. And these are 2 by 2, 2 by 1s. So you cannot add them together. So except it's a case where it tells you that it's a translation, you are always multiplying because all the others are multiplication. Translation is addition of the matrices and the vector or that you'll be using. So now the matrix of transformation first. So 0, 1, 1, 0. Open bracket, and then you use the matrix, the coordinate that you'll be focused on. So x. So x is 1, 1. Now there are 2 ways you can do it. You are allowed to actually work out all of them once, or if it's sometimes it's easier that you don't get confused to work them out individually. So I'll just work them individually. So normal multiplication, row by column, 0 times 1 plus 1 times 1. Same thing, 1 times 1 plus 0 times 1. And we know 0, 1, 0 plus 1. So that's 1 at the top. 1 times 1, that's 1, 0. So that's 1, 1. So x is still 1, 1. Then you do the same thing for y. So it's the same matrix. So 0, 1. So 0, 1, 1, 0. Y is 3, 1. And you multiply same way. So row 0 times 3 plus 1 times 1. 1 times 3 plus 0 times 1. So we'll just simplify. So 0 times 3 is 0. 1 times 1 is 1. 1 times 3 is 3 plus 0 times 1, that's 3 here. So that's y. And then we do z. So 0, 1, 1, 0. And z is 3, 4. Multiply 0 times 3 plus 1 times 4. 1 times 3 plus 0 times 4. Equals 0, 3, 0. 1 times that gives you 4 there. 1 times 3, 0 times 4. So that leaves us with a 3 here. So x prime, the image of x would still be 1, 1. Y. The image of y is 1, 3. And the image of z is 4, 3. Now, if you look at these, they are all reversed. So if they're reversed, it then means that it was a form of reflection that would have happened, that they would have been reflected in one of the lines, or yeah, so they would have been reflected somehow in one of the lines of reflection. So that's all there is to transformation for the simplest parts of it. There will be cases where it's translation. Translation is just, say you have these two and the vector, you just simply add them together. And for enlargement, it would be a case where this is 0, 3, 3, 0, and you still multiply them and it gets bigger. The numbers would get bigger. Or if it's a smaller number, it gets smaller. Rotation is the same principle. It's just that there will be negative signs in this that will change the values of it. So the essence is, for the transformations, it's multiplying the vector or the matrix by the coordinate of the thing, and it changes the position or the location of the coordinate, or it reflects the coordinates and stuff. So I hope this helps you with the basic understanding of transformation and matrices.